Wow, on that happy note.
Yeah, let's all go have a drink.
Yeah. There's probably some questions out there. Thank you so much for that. It was lots of information. I'm glad you didn't go into every thing in the formula for the volume loss.
Oh, I wanted to. I wanted to.
But I'm sure there's some questions out there. I know I have a few, but I'll save and see what folks. Let's see. I think Tony, can you I don't know if everybody is jointly muted or if people can control their own mute button, but why don't we go ahead with some questions? You could raise your hand if you want, or just unmute yourself and we can.
And there's some questions in the chat as well.
I didn't. Oh, there we go. Yes. First question showed up. What is your confidence in the PRISM data at higher elevations for temp and precip with so few stations at high elevations?
Okay. I'll answer this, and then you have a hand raised here with
Yep.
Robert Flood here. So yeah, okay. What's the confidence in the PRISM data at high elevations? Yeah, great question, and you're absolutely right. The data is not as good in the alpine areas because there's fewer stations, and it does make some assumptions about the rate at which the air cools with elevation. And they definitely changed that seasonally. I think it's good enough for the kind of things that we're doing. I don't think I would necessarily say, oh, that's the climate of my house if it was up there. But I think its spatial variation is good enough for what we're doing. And frankly, it's the best we got. There are other ways to estimate this, and they all have their issues with accuracy in isolated locations, but they're all very similar to each other. They don't, so that provides confidence that these different techniques provide similar results. So I have confidence enough in this data.
Did you see the second half of that question about can we accept the common adiabatic lapse rate? And I think you kind of addressed that, but if you.
Yeah, well, what they do is they do use lapse rates that change with time. So it's not just a lapse rate, and so they try to capture the seasonal variation of lapse rates.
Okay. Mr. Flood, Robert Flood, you had your hand up.
Yeah, my question basically involves temperature. When we moved in retirement to an area just outside Port Angeles, one of the benefits that attracted us were the cooler temperatures in summertime, a lot less than where we had come from. And my understanding at the time was that there was enough snow and ice mass on top of the Olympics that the winds coming over the mountains, in essence, had the effect of an air conditioner for us in this region. So with the loss of some of the annual snow and the loss of ice, would the projection be that the temperatures would, in the long term, rise here north of the Olympics?
Yeah, that's a good question. That's called the snow albedo feedback, that not only does the snow and ice cool the air as it flows over it, but also the brightness reflects solar radiation that also helps keep the air and landscape cool. And without that, everything warms up. Pursuant to specifically your question in your area, I don't know the extent to which the downstream effects would be felt. So, if you're, say, 50 miles from where all the snow and ice is, do you still feel a cooling effect from that, and how that would change as the snow and ice disappears? I don't know. If you're right near it, absolutely. Like if you're within a few miles of it, yeah, absolutely. If you're really far away from it, I don't think it's much because there's so much land, ice-free land between you and the snow and ice that it would warm up the air quite a bit. So it's a reasonable question. My guess is not much.
Thank you.
Ed Shad, you have a question?
Hi, thank you so much. What a great presentation this has been. Speaking of downstream effects, I'm thinking about the probable impacts to stream hydrology, really not just stream hydrology, but just water in general. And what it sounds like from what you're saying is that we're going to see flashier flooding generally in the wintertime and probably summers, probably higher sedimentation during winter floods, partly because of the disappearance of the glaciers themselves. And so I guess I'm interested in knowing what do you know about connections with other scientists in hydrology, in fisheries, etc.
Okay, yeah. Let me postpone my thoughts on that just for a second because Bill Backus wrote, and he's absolutely right, back to Robert Flood's question, that the Pacific Ocean really dominates temperatures rather than the mountain snows. And that's absolutely right. If you have a huge pool of 45-degree water sitting out there, that's going to keep everything much cooler than if you're in Iowa or something. Okay, so back to your question. Yeah, so what's going to happen is during this period of transition, the glaciers will be pumping out more water than they would normally if they were in equilibrium. As they lose their ice to increase melt, they're putting out more water than they would if they're under more equilibrium conditions. So right now, the streams are flowing during the summer, are flowing more full than they would otherwise. And as these glaciers shrink, however, they will pump out less water with time because they're just smaller. And therefore, their ability to buffer against droughts will be reduced. Because right now, glaciers are great buffers against drought. You know, you have warm summer temperatures, glaciers are melting like crazy, stream flows are just doing fine. During cool summers, you have lots of rain, you don't have as much evaporation, streams do fine. So glaciers really help to maintain stream flow. And as they shrink and disappear, the landscape, the riparian landscape, the high alpine ecosystem will be more subject to drought conditions. Your other part of your question in terms of floods and sediment and all that, that's more of a snow question. And what'll happen is as you have less, well, the snow is a great barrier because if you have snow on rain, if the rain doesn't melt the snow, it provides a more gentle entry into the landscape as the water filters through the snow and enters the ground. Without the snow, you just have this atmosphere of water just hitting the landscape immediately. So you're going to have more erosion in the higher alpine areas. And you're right, you'll have flash floods more frequently, and you should have greater erosion. So that's all, I think, in the picture for the future.
Thank you. And just wanted to notice that Bill filled in. And for those of you who don't know, Bill Backus is joining us from out at Mora, where he's doing coastal surveys and has been doing a lot of the field work in the Olympics, monitoring the glaciers here for decades, and has this finger on some of the research. And as he wrote in 2015, that they calculated that 26% of it was, I think it was the summer runoff in the Hoh was coming directly from the glaciers. So thinking about that being gone, that quarter of the flow in the Hoh River, when those glaciers disappear, that keeps it cool, and it's just a lot of the volume of the river. Something to think about. Mike Dawson, you have a question?
Yeah, I'm just curious. Can you talk more about what percent of deglaciation you can attribute to human-caused climate change as opposed to, longer term changes in climate that have also reduced the amount of glaciers we have?
Yeah, that's also a good question. I didn't do this study myself, but there was a paper, I don't know, about 5 or 6 years ago that did what they call an attribution study, where they looked at the amount of greenhouse gases in the atmosphere and did some modeling. They subtracted out the anthropogenic contribution to greenhouse gases and then see how the glaciers reacted. And the conclusion of that paper was roughly a third to a half of the current glacier recession is due to anthropogenic contribution to warming.
I want to follow up on that, if I may, with a question. The other third to a half, I'm trying to think where we are in what would be the PDO cycle. I think we would be in a colder, wetter period now, I think, but I
think so, yeah.
And I was wondering if some of what's going on with the oceanic conditions or ocean conditions with the warm blob thing, the changes in wind, if the signature of the PDO, I thought I recall that it wasn't as neat as it used to be, that it seemed to be breaking down a little bit. And so I was just curious about some of those non-anthropogenic cycles and the strength of those signals in.
Well, that's what we're thinking as well, that that the PDO isn't getting as cold as it used to get, and climate warming is minimizing or reducing the effect of the PDO cool periods. So we're still getting all the rain, but we're not getting as much snow, and that's been, I think, one of the issues with the glaciers.
All right, we got Ed has his hand up again, and then Robert after that. Ed, go ahead.
Sorry, I just didn't put it down.
Okay.
Thank you.
Robert, do you have another question? You're on mute, Robert.
Yeah, on a real positive note, when the big one hits, we talk about liquefaction, here in and around the northern part of the peninsula, assuming that there's going to be liquefaction up in the area of the glaciers and the snow. Have there been any studies on what that would mean for us down here at the lower elevations?
In response to earthquakes?
Yeah, such as, a really big one.
Yeah. The short answer is no. Nobody's done anything on that. However, there's a different situation going on with the glaciers that's relevant to your question, and that is, as the glaciers retreat, they leave these moraines on the border of the glaciers, and these are rock accumulations, partly from the glacier itself that moves rock down and then dumps it along the margin of the glacier. And then also, depending on the geologic situation, you could have small debris avalanches off the side of the valley onto the edge of the glacier, such that when the glacier retreats, you're left with these oversteepened linear piles of rock, and oversteepened because the glacier used to be there, buttressing the one side of the rock accumulation. So when the glacier retreats, it's an oversteepened pile of rock that then becomes mobilized during intense rainstorms, which enters the streams and then flows downstream, bulking up and then quickly becomes a debris flow. So then you have these debris flows from these retreating glaciers. And we've seen this here on Mount Hood, Mount Rainier. And that's partly because they are huge moraines, but you should see something similar, maybe smaller in magnitude in the Olympics.
Okay, thank you.
I have a follow-up, and then I'll get to John's question here in the chat. This is something that Bill might be able to address. When I was still working for the park, and we had follow-up 2015 inventory data using, I think, the standard definitions of what a glacier was. We had gone from like 266 from Rich Spicer's data. I think we had numbers of down to like 148. So I'm not sure if we're doing apples and oranges or the standard like 0.01, because that's like over 100 glaciers that we lost, and the conclusions thing had like 35. So I'm not sure where the differences are there, but maybe it's big glaciers becoming 2 or 3. I'm not sure. If you have any insight, maybe Bill would have insight. That makes sense.
Can you guys hear me? This is Bill.
Yep.
Yeah, so Andrew, I haven't quite been able to figure that out, and we should probably kind of stick our heads together at some point on that. The numbers that you're talking about, Janice, we used a few different years. We used Steve Wilson's work, and Steve was doing this with Andrew down at Portland State University, one of his grad students. And we used the 2009 imagery rather than the 2006. And then our latest numbers were based on work done by Justin, who was a co-author on this paper with you, Andrew. So we haven't had the time to kind of get together and find out how, why our numbers differ somewhat. The percentages of area are almost the same. So I guess that's the question. And I don't know if you can answer it off the top of your head, Andrew, is why we kind of just came out. Justin came out when he did his analysis for us using 2015 imagery. He saw a larger loss of glaciers than you show in your recent publication and analysis. So I don't know if you can answer that or if it's something we just need to touch on later.
Yeah, this is a little bit of inside baseball here. So I'll make it brief. And you're right, Janice, it depends on the way you count it. What Rich Spicer did and what we could not undo was he determined the glacier area within each watershed, the first order stream, so the smallest watersheds. And he just he just estimated the area for those little watersheds. So you might have four little glaciers in this little watershed, but he only calculated the area for all of those. So that kind of represents one feature. So in order to make our study, which was like Steve Wilson and Justin and everybody, to make our study compatible with that original data, we had to group our glaciers the way he did in order to do the analysis and change with time. Forthcoming studies, and we have a 2015 updated glacier map as well. That would be way more consistent with Wilson and Justin's work.
Thanks for that explanation. That makes more sense. And let's see, I think there's a question in the chat from John Stednick. Any comments on the dust on snow phenomena as observed in the Southwest? We had ash deposits here in the Olympics, but dust, question mark.
Yeah, that's actually been studied. by a number of different people up on Blue Glacier, and it does have an important effect. One of the issues is not only you have dust, and then, say a wintertime dust, and then snow falls on top of it. When the snow melts, the larger particles stay on the surface. And if you've been up in the high alpine in late summer, the snow is kind of dirty because the larger particles stay on the surface, as well as more stuff locally accumulates on it, such that it lowers the albedo or decreases the reflectivity of the ice and snow, and it melts faster. So yeah, that's a big issue for sure. And these forest fires don't help. It's one of these things that it seems like as the glaciers get smaller, there's more and more things that affect the glaciers to accelerate their recession. So a big glacier, sure, if you get some particles on it, yeah, it'll melt a little faster, but no big deal. It's a big glacier. Little glaciers, that's a big deal. And they become much more sensitive to these issues. So that's a very important process you highlighted.
Great. I had a question from a public relations end of things. We all heard it was pretty well distributed, and Al Gore had an inconvenient truth about that there were some dates given for the disappearance of glaciers at Glacier National Park. Depending on who you talk to, exactly when, but sometime in the next decade or two. And I was wondering if you, after the publication of this paper last month, have you been getting a lot of inquiries and people talking about that? I think Glacier was sort of the poster child. Glacier National Park was sort of the poster child, and I'm curious how much interest there has been either nationally or internationally about sort of giving a date to Olympics glaciers disappearing.
Oh, yeah, there's been a lot of interest, actually. I was a little surprised, and it's continuing. I have 2 phone meetings this week about that, and it's been, well over a month since this came out. So, yeah.
I'm not surprised. Any other questions out there? We've got the expert here. There's a nice thank you in the chat from Robert Flood. Otherwise, any other I don't see any other hands up. I don't see anything else in the chat. Believe it or not, I don't even have any more questions on that. Oh wait, Ed Chad put his hand up. Ed, go ahead.
Thanks. Since there's apparently some time, I'll just ask this. I know that your modeling graphs looked at business as usual scenario and a moderate reduction scenario. Have you run anything the most optimistic possible scenario? Just wondering how much difference that would make, and I imagine that in the long run, not very much, but just thought I'd ask.
That's a really reasonable thing to do, and I guess I show my pessimism by not running it because I don't think we're going to do it. So that's kind of what I thought during the time. These runs are kind of complicated and time intensive, and I thought, oh, we'll never do the right thing. So I'm just going to do business as usual and a mild decrease in greenhouse gases to see if that really affects anything, because we're not going to go to net zero. And I don't know. I guess I have to apologize for that, but that's my cynicism.
Valid. I guess I have a follow-up question. So I think it was the one that can't remember who asked it. Maybe Mike, about the percentages with the attribution study to anthropogenic versus natural background variation. And I must admit, I was sort of surprised that it was only 1/3 to 1/2 in that attribution study. And I was curious about the other, 2/3 to 1/2 given maybe the changes in the PDO signature, and so just curious if you have any insights on that.
No, but I will say, you know, this paper was published, like I said, 5 or 6 years ago, which means it was based on data and work another probably 5 years before that. So it's not up to date, and things might have accelerated. So
Yeah, because I was curious about things like El Nino and La Nina and sea surface temperatures in the southern hemisphere, and are those patterns changing, and there's cycles, and do we?
yeah, you know, from our study, correlating the glacier change with these various climate indices, PDO, PNA, we did El Nino, we did sunspots for fun, and you know, there really wasn't anything out there other than the two that I mentioned, the PDO, PNA. The El Nino flickers too much, I think, you know, from every year it kind of does something else, and it doesn't. And because where we are geographically, we're kind of on the hinge between it really affecting the north and really affecting California, and sometimes it affects us, sometimes it doesn't. So that signal's too noisy, I think, for it to correlate with any of the changes or climate we see.
We have a new hand up. Case, call.
Good evening, and thank you very much for a wonderful presentation. Thank you for moderating this, Janice. My question is whether or not you have any information from the glaciers in Europe, in the Alps, and in other major glaciated areas, whether it's the Andes or what have you, and whether or not there are similar types of studies occurring there, and whether the general prediction or the rate of loss of mass is similar.
Yes to everything you asked. A lot of our graphs look very similar to their graphs. I'm thinking about percent change with the original area of the glacier, or the percent change with elevation. In terms of glacier loss in the future, I'm a little vaguer on that, but I know it's similar. I don't know if they've said anything. I don't think it's 2070 for them. They might be more like 2150 or something like that. But it's all kind of going in the same direction.
Thank you.
The only good news in this situation is the crater glacier in Mount St. Helens. After the St. Helens blew up, it created this wonderful snow accumulator, and it's north facing, so it's protected from the sun. And between the direct snowfall and avalanching of rocks, a new glacier has been created that's advancing at about 6 feet a year. So that's the only advancing glacier that I'm aware of in North America. I take that back. In the continental U.S., there's some other advancing glaciers for other reasons. But anyway, the only truly advancing glacier in the U.S., continental U.S.
Maybe we should hope for some more eruptions. Who knows?
Yeah, right. Yeah, Mount Olympus, right.
It's a shame the
erupts.
Olympics aren't volcanic. Darn. Katie, you have a hand up?
Yes, thank you very much for this talk. I'm wondering if the glaciers in the Andes are doing better.
There's no good news out there. Sorry.
Okay, I'm just curious. There's different topography, et cetera.
Yeah,
They're much higher. I know they're really high.
Yeah, they're really high, and you're absolutely right. And you'd think they'd be doing better because they're colder, but they're not down there. They're also shrinking quite a bit. And in the Andes, I gather they are more dependent. Some of the villages are more dependent on that meltwater than we are here in the Western US. So it's a more critical issue for them down there in that regard.
We have another question in the chat from Alex. What are the implications as regards to salmon viability and replenishment of aquifers? So two kind of separate ideas here.
Um, yeah, salmon don't really like glacial streams because they're too cloudy. There's too much sediment in it. Bull trout and other cold adapted species think they're great. So they're going to be in trouble as the streams warm up due to the lack of glacial melt cooling it, as well as the volume or discharge of water from these glaciers. So that's going to be an issue. Aquifers, no problem, because we're getting all this rain and we'll continue to get rain, and the aquifers will tend to be full all the time. Might even get more rain if you believe the climate models. You know, wetter places get wetter. So there we are.
As I listen to the rain pounding down outside my window in June.
Yeah, exactly.
All right, I think we're winding down. We're getting near 8 o'clock. Any last minute for any questions? But otherwise, I know on behalf of Olympic Climate Action, I wanted to thank you so much, Andrew. As soon as Paul told us that he reached out to you and you said you were available, everybody was tickled to think that you would be willing to share your expertise. Such a timely thing, and as you said, you're getting lots of inquiries from media, and there's lots of curiosity all over. I think the summary of your paper was published on the front page of our local newspaper on Earth Day.
Oh, wow.
And we had a program. Yeah, we had a program down at the city here, and so it was a good conversation starter for folks.
So let me end on a positive note. Those of you might be aware that about the ozone crisis and the ozone hole, and the ozone hole was increasing in size and in severity, where there was less and less ozone in there. And as many of us know, it was due to the production of CFCs, or chlorofluorocarbons, from hairspray and other refrigerants. Through international protocol, we've stopped doing that. And I think it's only China now that is producing CFCs. But nonetheless, the ozone hole has stopped growing. And if we get China online and maybe some other countries, it'll actually begin to shrink. So therefore, we have the ability to change our climate if we want to. It's just a matter of, do we have the commitment to do it? And that's what it is. This is not a foregone conclusion if we don't want it to be.
That is a happy note. As someone said, thank God this is mostly human caused, because that means we can actually do something about it.
Right, exactly.
Oh, that's very good.
Thank you so much.
Yeah, thank you, Andrew.
Thank you so much for sharing, and good night, everyone. And again, if you know other folks that wanted to come tonight but weren't able to, we will eventually be able to post this on our website. And have a wonderful summer evening, wonderful solstice. And again, Andrew, thanks so much. I look forward to follow-up publication.
Okay, thank you.